this video, we're going to take a look at solving systems of equations through the substitution method. So before we looked at solving an equation by graphing. So to graph, we graph the two lines, and if they intersected, that is where we solved our systems of equations. Instead of graphing, we can solve it algebraically as well. The first step, what we're going to do is solve for one of these variables. We have a couple of variables to choose from. We can either solve for this x, or we can solve for this y, or we can solve for this x, or solve for this y. Now we want to work smart. We can do any of them, but there's going to be one that's easier than the others. And hopefully you're saying, oh, Mr. Wilmus, it's this one. This y would be a lot easier to get all by itself than the other ones. It'll require less steps. So to do that, to get this y by itself, all we have to do is subtract 2x on both sides. So if we subtract 2x on both sides, I get y is equal to 4 minus 2x, right? Now this is why it's called substitution method. It's called substitution method because we know that y is equal to this value. Since it's equal to this value, we're going to take it and we're going to substitute it in for this y. Alright? So that's going to look like this. So we'll have 3x plus 5. And instead of y, we're going to substitute in this 4 minus 2x. And that is equal to 13. Now we only have one variable in our equation. We have an x and we have another x. Before we had an x and a y. We can't solve equations when we have two variables. Not yet anyway. So we have one variable now, an x and an x. So we can solve for that x using our usual steps that we've been doing all year. So we're going to go ahead and distribute. 5 times 4 is 20 minus 10x is equal to 13. And we can combine like terms, this 3x and this minus 10x, and we get negative 7x plus 20 is equal to 13. I'm going to subtract 20 on both sides, so I get negative 7x is equal to negative 7. If I divide by negative 7 on both sides, I get x is equal to 1. So I get x is equal to 1. That's one of my answers. Now I need a y answer. So to figure out my y answer, I can substitute this back in, this x equals 1, into any of my equations. I think this one here looks easy. This y equals 4 minus 2x. So if I substitute this into here, I get y is equal to 4 minus 2 times 1. So we're going to get y is equal to 4 minus 2, which is 2. So the answer to this problem, or where these two lines would intersect at, if we graph them, is 1, 2. It's as easy as that. So in this problem, I'm going to show you another substitution problem, but we're going to get a slightly different answer. Alright, so we're going to do the same steps as before. The first step is we're going to solve for a variable. So we could solve for any of our x's and y's. I think that this x or y over here would be the easiest to solve for. I'm going to go ahead and solve for this x. So to do that, I subtract y from both sides, right? And I get x is equal to 3 minus y. Now, substitution. So I'm going to substitute, since I know x is equal to that, I'm going to substitute it in for that x right there. So if I substitute it in, I get 2 times 3 minus y plus 2y is equal to 6. Now I'm going to go ahead and distribute this out, and I get 6 minus 2y plus 2y equals 6. I can combine like terms now. I have a minus 2y and a plus 2y. If I combine those two together, they actually cancel out. So I get 6 equals 6. My variable disappeared. And we know that 6 does equal 6. So this is a special type of graph. If your variables ever cancel out and we get something that is true, this means then we have infinite answers. If we ever get something, say, instead of 6 equals 6, I got 4 equals 6, which is false, right? Then we would have no answers. So if we graph these, I'll show you what those two look like. Infinite answers, we have our xy plane. It would be a line and then the exact, so this is the first equation. The second equation is going to be right on top of that. So it has infinite times where it intersects at. Obviously, I can't draw a line right on top of the other line very well, but you get the point. So in order to get something like this, no answers, we're going to end up with two lines that are parallel. They're never going to intersect. So we're going to have no answer for this equation.